formula for these problems. Los Angeles to worker have an average commute of 33 minutes and a standard deviation of 12. And it says it's normally distributed. Your distribution is just your mean and your standard deviation. Now when you're finding probability, you either use norm inverse or norm distribution. In this case, find the probability that a randomly selected LA worker has a commute that is longer than 30 minutes. Now when you're using the formula, it's giving you the percent below. So if we want the percent above, once we find that answer, we're going to go 1 minus it to get the percent above. So first, we click where we want our answer, click over here and equals, and start to type norm to come up. There's normal distribution and normal inverse. When you want the percent, you use the normal distribution, because then you put your x value, which they said was 30 minutes, comma, your mean, 33, which is right here, standard deviation 12, and you separate these by commas. And then, for some reason, this has something weird in here. I must have bumped something, but it should only be 30. 30 is our x value, 30, and it even tells you x, mean, standard deviation, and then cumulative. Cumulative is 1, because under the curve is a total of 1, 100%. And then just hit enter. Now this is the percent below 30. We wanted the percent above. So then in the next row you could go, put your equal sign, 1 minus this value, and hit enter. And then there's your 5987. When you're finding the next one, find the 75th percentile to commute. This one, they're giving us a percent. We're looking for a number. And a percentile is the percent below that number. So the 75th percentile would mean 75% of the data is below it. So we come over here, click where we want our answer. Click over here, put your equals, type norm. And this time, since we want the value, we have 75%, you use the second one. Notice it wants the probability. It wants it as a decimal. So 75% would be 0.75, comma, your mean, comma, your standard deviation. And that's all you need. Probability, mean, standard deviation, and hit enter. You get 41 point, they said 4 decimal places, 0939. Try one more. So for this one again, we put our mean and our standard deviation. Median recovery time is your mean. They're equal when it's normally distributed. What is the z-score? What is the probability of spending more than 3.7 days in recovery? So more than, again, we go over here and click, put our equal norm. We're looking for probability, so we want the normal distribution. Our x value is 3.7, comma, the mean, which was 4, standard deviation 1.8, and cumulative is 1. And then hit enter. Now this is the percent below 3.7. They want probability of spending more than 3.7 days. So since they want more than, click over here, put equals 1 minus our value, and hit enter. And the next one is going between two values. The probability of spending between 3.1 and 3.9 days in recovery. So if we do 3.9, it's going to give us from 3.9 and below. So, but we want between these two values. So if we find the 3.9, and then if we subtract the 3.1, it's going to leave us what's in between. So you want to find the 3.9, subtract the 3.1, and it gives you what's in between them. Let me delete these. Okay, so first we'll find the percent below 3.9. Come over here, put equals, norm, and we're looking for the percent, so we'll do distribution. Our x value was 3.9, comma, the mean is 4, standard deviation 1.8, comma, and then 1, because it's cumulative. Now we need to do the exact same thing, equals norm for the 3.1. 3.1, comma, 4, comma, 1.8, comma 1. Oops, I didn't click. Must not have double clicked the norm. Make sure that it's a double click. There we go. 3.1, comma 4, comma 1.8, and 1. So this first one is below 3.9, the second one's below 3.1, so we need to subtract them. And you can plug it into your calculator, but if you put your equal sign, then you can put A1 minus A2, and hit enter, and there's your answer. '75th percentile means 75% of the data is below the number. This one's giving us the percent. So we use equals, norm, and we use the inverse one. Probability is a decimal, 0.75, comma, the mean, which was 4, 1.8 for a standard deviation, and hit enter. And there's your answer. The other ones that come up are quartiles. Find the minimum number for the upper quartile. Okay, quartiles you have quartiles. This is your smallest number. And then you have your Q1, your median, Q2. So this is either your lower quartile or Q1, your upper quartile or Q2. It's interchangeable depending on the book. And then this is the largest number. In between is 25% of the data. So if you're looking for the lower quartile, you'd use 0.25 to find it. If you're looking for the upper quartile, this should be a 3. If you're looking for the upper quartile, 25, 25, 25, it's 75% of the data. So if we're looking for, let's do this one. If you're looking for the minimum number for the upper quartile, that would be 75% of the data. And so we would go equals, norm, and we have the percent, so we're using the inverse one, 0.75, comma, the mean, which was 14, standard deviation 6, and hit enter, and our number 18.0469. Part B, find Find the probability that an unafflicted person with a kidney stone will take longer than 16 days. Okay, so we would do, click up by the function, equals the norm. We have a number, so we're using the first one. The number we have is 16, comma, the mean, 14, comma, 6, comma, 1 for cumulative. Now remember, this is below. We want person with kidney stone will take longer than 16 days. So we want longer than. So we want equals 1 minus the answer we got.